August 26, 2014, a historic moment when New Horizons crossed Neptune's orbit. This spacecraft was heading straight towards Pluto, but this moment was also special for us. Exactly 25 years earlier, in August 1989, Voyager 2 also flew by Neptune, and we were repeating this history once again. During this mission, we explored Pluto, which is known as the King of the Kuiper Belt, as well as several other Kuiper Belt objects. But now we would like to take another look at the Voyagers, because they could have done this work too. But the Voyagers were launched first, in 1977, and throughout the 1980s, both these spacecraft, Voyager 1 and Voyager 2, kept making history. That's why the missions of both spacecraft were extended further. But Voyager 1, after doing a flyby of Saturn, could have gone to Pluto, but did it go? No, so what was it that stopped us from doing a mission 25 years ago that we could have done? What if this happened 25 years ago? Voyager 1 would have done a flyby of Pluto. We'll find out in today's video. On November 12, 1980, Voyager 1 was doing a flyby at the closest distance to Saturn. Where National Aeronautics and Space Administration found methane rivers and an atmosphere. Clouds formed there and it even rained. The chances of finding life on this methane-filled world were much higher. That's why National Aeronautics and Space Administration turned away from Pluto, and Pluto remained unexplored for a long time. But what would have happened? If Voyager 1 had been sent directly to Pluto instead of Titan, Voyager 1 would have reached Pluto by 1986. And by this time, Voyager 2 was still moving ahead after studying Uranus. New Horizons reached Pluto in 2015, but if Voyager 1 had done a direct flyby of Pluto, maybe we would have accomplished this feat 30 years earlier. But this journey wouldn't have been so easy. A lot of technical and psychological challenges would have been waiting for us. Darkness, an unknown journey. Our biggest challenge was knowing very little about Pluto at the time. And how is it connected to our solar system? What does it contribute to the solar system? And what can our science gain by exploring it? There were so many such questions, all of which had a big question mark over them. Otherwise, it was 1986. But we discovered Pluto's atmosphere about 2 years later in 1988. Until then, Pluto had only appeared as a dot in the sky. We had no idea what it looked like or what it was like. About 8 years later, in 1994, the Hubble Space Telescope saw Pluto for the first time, and we saw Pluto's surface for the first time. The important thing to note here is that in 1986, we didn't even know about Pluto's context. Where did it actually originate from, and how did this body become connected to our solar system? We couldn't even call it a Kuiper Belt object because the Kuiper Belt objects were discovered in 1992. About 6 years after 1986 even, we didn't even know that something like a dwarf planet existed. And even beyond Neptune, there are many things left to explore. At that time in 1986, we only knew about one thing that was similar to Pluto, and that was Neptune's moon, Triton. But Voyager 2 was still going to take another 3 years to reach it. We didn't know what to expect from Triton, but we couldn't wait 3 years. However, we did know quite well about Pluto's size and the size of its moon, Charon. We also knew that their surfaces could be made of nitrogen and carbon monoxide ice. And as for the atmosphere, well, it hadn't even been discovered at that time. We had no idea about Pluto's entire system, like how many moons it had. And this information is very important for any flyby mission, so that we can do all the calculations keeping in mind the gravitational interactions of the bodies present there. All of Pluto's moons were discovered between 2005 and 2012. Overall, if we look at it, in 1986, we did have the option to fly by Pluto, but apart from Pluto's address, we didn't know anything else. It would have been like driving with your eyes closed in an unknown place, where you have no idea what could happen at any moment. And maybe no one would want to take such a risk. Voyager 1 featured cameras, a spectrometer, plasma experiments, and a magnetometer. Apart from this, it also had a radioactive battery and some default instruments which obviously could explore Pluto. In 1980, when deciding to go to Pluto, Neptune and Pluto were nearly the same distance away. Now, since Voyager 1's instruments are still working even today, so this means that they would have easily worked all the way to Pluto and we would have successfully completed the journey to Pluto. But there's something interesting here as well to know. It's true that Voyager 1 was capable of mapping Pluto and its moon Charon. It could study Pluto's atmosphere and its basic properties, but the Voyager team didn't design this mission to study small moons. Those were about to be found near Pluto, and Voyager wouldn't have been able to explore Pluto in as much detail as we could with New Horizons. And that's because Voyager used sensors from the 1970s, and after that, there was a big revolution in the world of computer processors and sensors. And after that, when we worked on the sensors to be used in New Horizons at the beginning of the 21st century, we can clearly see the gap of technological advancement here. You can get an idea of this from this very fact. The Voyager 1's ultraviolet spectrometer had only 2 pixels, but New Horizons' ALICE ultraviolet spectrometer had more than 32,000 pixels, which allowed it to study Pluto 16,000 times more efficiently than Voyager. New Horizons had much better mapping cameras than Voyager, as well as a radio science experiment that was meant to study Pluto's atmospheric pressure and temperature. In addition, a dust impact detector was also installed on New Horizons. But Voyager didn't have any such technology, but Voyager had a big antenna and a large battery backup as well. Because of this, it could transmit signals about 10 times faster than New Horizons. But its memory was much less compared to New Horizons. Because of this, the amount of data we would get from Voyager would be very little. So from here, we understand that if Voyager 1 had visited Pluto, we would have gotten some data. But the quality of that data wouldn't have been as good as what we got from New Horizons. Discoveries and data. If Voyager 1 had really been sent towards Pluto in 1986 for sure, all those discoveries would have been credited to Voyager 1 today. The ones we made in 2015, but we would have had to compromise here. With data and diversity, New Horizons provided us with 10 times more data, whereas in the case of Voyager 1, this data would have been limited. In 1986, we didn't even know about the Kuiper Belt and we might have missed it. Except for Pluto, we wouldn't have studied any other Kuiper Belt object, we would have just kept moving forward in that dark, empty space. But that didn't happen with New Horizons. In the New Horizons mission, we studied several primordial Kuiper Belt objects even after Pluto. Just imagine how it would have felt if just a week before reaching Pluto, we found out that Pluto actually has its own atmosphere. Besides that, its small moons orbit around it. There's much more nitrogen on its surface than we had estimated, and methane is also dominating its atmosphere. It would have been really amazing to find this out just a week earlier, but the Voyager team definitely wishes they had known all this before. But no mistake. Here, both spacecrafts are extraordinary, both have their own place in history, and both are the best in their own way. The teams, engineers, and scientists working on both projects deserve appreciation. Their decisions and leadership have given all of humanity a chance to step outside this solar system. They are the real stars of this story, and yes, so are these. Whenever the story of stepping out of the solar system is told in the future, they will definitely be remembered, and Pluto, regardless of its age or origin, we have only just begun to learn about it. and the decision that National Aeronautics and Space Administration and the Voyager team made about 36 years ago to not go to Pluto. Because of that, we were able to send another mission, a thrill, a journey. We were able to feel that excitement in the darkness of space. About 42 years ago from today, on September 5, 1977, the Voyager missions were launched. This spacecraft is now in interstellar space. Speaking of the Voyager mission, you probably already know that it was made by humans. This is the only object that has traveled the farthest distance in space so far. So far, Voyager 1 has traveled approximately 21.7 billion kilometers. But the most interesting thing is that even after being so far from us, this spacecraft is still in contact with us. We are still continuously tracking its location even today. But after all, for how long and up to what distance will we be able to see it, and up to what distance will we be able to track it? In the end, how will the Voyager mission come to an end? In 1964, aerospace engineer Gary Flendro noticed that in the 1970s, Jupiter, Saturn, and Neptune were going to align in a straight line. Then he presented this concept, called the Grand Tour, to the scientific community. But unfortunately, due to some reasons, this program could not be started as planned and the mission was cancelled. But based on this same concept, National Aeronautics and Space Administration launched another mission in 1977. It was named the Voyager program, and under this program, 2 spacecraft were launched, which included Voyager 1 and Voyager 2. They have been able to observe all the planets up close. But what was initially thought did not happen, and Pluto was left out of this program. What was thought did not happen, and Pluto was left out of this program. However, 41 years after launch, the Voyager mission continues its journey. Today, if you are watching this video, this spacecraft has traveled about 21.7 billion kilometers. On August 25, 2012, Voyager exited our solar system. And with this, it was the first time that an object made by humans had stepped outside our solar system. Scientists can still trace it after leaving, and it is still in contact with us today, but for how long Voyager 1 will remain in contact with us is a big question today. But before answering this question, we need to understand how Voyager 1 actually communicates with us, or in what way. We receive data from Voyager 1. To receive data from Voyager 1 first, a 20 kilowatt radio signal is sent towards Voyager 1 through large telescopes installed on Earth. It takes the radio signal about 20 hours to complete this journey. After that, the sensitive antennas installed on Voyager 1 catch the signal sent from Earth. After this, Voyager 1 sends a 20-watt radio signal towards Earth. We have to amplify these signals coming towards our Earth. Because during such a long journey, the signal becomes very weak. By the time the signal reaches Earth, it has become so weak that it becomes very difficult for us to even detect it. But this task is made possible by the Deep Space Network, that is, the Deep Space Network. This Deep Space Network is a worldwide network of radio observatories. The Deep Space Network is located in 3 places on Earth: Spain, the United States of America, and Australia. This radio observatory is so sensitive that it can easily catch even the weakest and most moderate frequencies. In the last 50 years, technology has developed a lot to detect signals coming from space. Voyager 1 runs on a radioisotope thermoelectric generator or radioisotope thermoelectric generator. An radioisotope thermoelectric generator cell contains a small electricity generator which generates electricity using uranium. As the amount of uranium decreases, it will take several years for the radioisotope thermoelectric generator cell to be completely depleted. This means that it is capable of providing its services for a very long time. Voyager 1 is currently moving forward at a speed of 17 kilometers per second, and the radioisotope thermoelectric generator cell installed in it is now gradually getting weaker. Because of this, its power has decreased significantly compared to before. In 1990, the cameras that were installed on Voyager 1 have also now been turned off, so that energy can be saved and it can be sent as far as possible and away. Scientists have claimed that Voyager 1 can only be operated until the year 2025, and it will remain in contact with us only until 2025. This is because after 2025, Voyager 1's radioisotope thermoelectric generator will not be able to generate enough electrical power to sufficiently supply the scientific instruments installed in it, and it will not be able to stay in continuous contact with us. That's why Voyager 1 will not remain in contact with us for much longer, and in this way, it can be said that Voyager 1 will come to an end by 2025. Voyager 1 currently has 11 scientific instruments on board. Talking about the instruments installed on Voyager 1, it includes television cameras, infrared and ultraviolet sensors, magnetometer, plasma detector, cosmic ray and charged particle sensors, along with several other instruments. It also has the capability to translate 55 languages. The material selected by National Aeronautics and Space Administration for the record also includes 150 analog encoded photos and various types of sounds, so that there is no difficulty in making contact through communication. But let me tell you, after so much time has passed, only 4 of the instruments installed in it are still working properly today. As its distance from us grows, its radioisotope thermoelectric generator will keep weakening until 2025. After that, the instruments installed in it will also be gradually shut down, or they will stop responding on their own. Along with this, its connection with Earth will also be lost, and in this way, Voyager 1 will get lost somewhere in space. In this dark black space, this mission has successfully accomplished many of its objectives so far, and it has achieved considerable success. The Voyager mission has gathered a lot of information about outer planets like Jupiter, Saturn, Uranus, and Neptune. In this way, today we can say that this mission has been quite successful to a large extent, and it has also been a very significant mission, which is still ongoing today. Launched in 1977, National Aeronautics and Space Administration as Voyager 1 and Voyager 2 spacecraft have embarked on an extraordinary journey for our human civilization, which today, while traveling through this infinite universe, have gone much farther than any man-made object. The first Voyager mission was designed for only a 5-year mission period to explore Jupiter and Saturn. But the Voyagers performed much better than the scientists expected. It completed all its missions on time and then was sent on to further missions. It was sent again on a never-ending journey through this infinite darkness-filled universe. And today, Voyager 1 is about 14 billion miles away from our Earth, and Voyager 2 isn't far behind. Both are continuously traveling through this infinite darkness-filled universe. But the question is, how did National Aeronautics and Space Administration manage to keep these spacecraft operational for such a long time, despite such great distances and harsh space conditions? To keep them alive, cleverness, skill, talent, and maybe a little bit of luck were also necessary. Carefully managing power, continuously providing accurate software updates, and overcoming technical challenges. The Voyager mission team has made every possible effort to keep these spacecraft's historic journey going. In today's video, we will explore the strategies and techniques that National Aeronautics and Space Administration has used to keep these Voyager spacecraft operational for more than 4 decades. What kind of challenges did these distant explorers face? And how did the mission team implement clever solutions? And what challenges lie ahead for these spacecraft as they continue their journey through interstellar space? At every turn of this story, an unsolved mystery is hidden. Will these Voyagers be able to succeed in revealing even more distant mysteries of this universe to us? How long can National Aeronautics and Space Administration keep these spacecraft operating? Voyager 1 and Voyager 2's journey is more than a milestone for space exploration. But this mission also teaches us how, even with limited resources and extreme conditions, innovation and determination can make the impossible possible. The power of RTGs, radioisotope thermoelectric generators, is one key reason why the Voyager spacecraft have remained operational for such a long time. Their power source, radioisotope thermoelectric generators or RTGs, are different from our traditional solar panels, which depend on sunlight. But they can't be used in deep space. That's why RTGs have been used in the Voyager spacecraft. RTGs convert the heat generated from the natural decay of radioactive material into electricity. For Voyager, the radioactive material used is plutonium-238. RTGs have provided the Voyager spacecraft with a continuous and reliable power supply, which has allowed Voyager to remain operational in deep space. This technology is especially ideal for missions where sunlight is limited or not available at all, like in the outer planets and interstellar space. The natural decay process of plutonium-238 generates heat, which is directly converted into electricity through thermoelectric materials. This process happens without any moving parts, which makes RTGs extremely reliable and long-lasting. However, over time, plutonium-238 decays, which gradually decreases the power output. But even then, the Voyager spacecrafts have far exceeded their expected lifespan. This is a result of the durability of the mission's design and engineering. How do RTGs work? RTGs are a type of nuclear battery that convert the heat produced by the decay of radioactive isotopes into electricity. Each Voyager spacecraft has 3 RTGs, which contain plutonium-238 oxide. When plutonium decays, it releases heat, which is continuously converted into electricity through thermocouples. Thermocouples are devices that generate voltage when there is a temperature difference. In 1977, when the Voyagers were launched, their RTGs were generating about 470 watts of electrical power. But as plutonium decayed over time, the heat and consequently the electrical power produced by the RTGs gradually decreased. Currently, the RTGs produce about 40% less power than originally, generating only around 250 watts. But even so, the Voyager spacecrafts have managed their power very efficiently. The mission team shut down non-essential systems immediately after their use was over, and the instruments have been very carefully prioritized so that they continue to collect scientific data even with limited power. And that's the reason why Voyager 1 and Voyager 2 are still sending us valuable information from interstellar space. The long-lasting capability of RTGs has made the Voyager mission an incredible example of how, with advanced technology and smart engineering, we can maintain our existence in deep space for a long time. For power management, to keep the Voyagers operational with decreasing power supply, National Aeronautics and Space Administration also carefully managed the spacecraft's power consumption. Over the years, the mission team has systematically turned off non-essential instruments and systems to conserve power. This approach has made it possible to keep critical systems like the communication system and some key scientific instruments operational. For example, the Voyager team has turned off the heaters of those instruments that are no longer in use. And also such non-essential systems like tape recorders, which used to store data before transmitting it. This careful power management has allowed the Voyagers to continue their mission despite their steadily decreasing energy reserves. Heat and thermal management is another big challenge with RTGs. Managing the heat generated by decaying plutonium. Just like on Earth, excess heat can become a problem even in the cold vacuum of space. The Voyagers are designed with a thermal control system that uses louvers for heat rejection and insulation to retain heat within the system. And this entire system regulates the spacecraft's internal temperature. This entire thermal management system keeps the instruments and electronics within their operational temperature range. As the RTG's power output decreases over time, the heat generated by them is also decreasing. As a result, keeping the spacecraft's systems warm is becoming difficult. That's why the team has to maintain a perfect balance between the spacecraft's power and thermal management, so that its critical components don't fail due to excessive cold temperatures. Apart from this, the Voyager team has also used innovative methods like adjusting the spacecraft's orientation so that the instrument can also be kept a little warm from the sun's heat. All this is like a complex dance where every decision affects the spacecraft's survival and scientific output. Despite all these challenges, Voyager 1 and Voyager 2 have continued their incredible journey to this day. Software updates and problem solving from billions of miles away. Keeping the Voyager spacecraft operational was not just possible by managing power, but maintaining the health of their systems and software was just as important. In the past years, the Voyager mission team has troubleshooted many problems. Several critical software updates were also sent to Voyager, and many creative solutions were devised. That too from billions of miles away. The most remarkable thing about the Voyager mission is that these spacecraft have received software updates despite such vast distances. In the beginning, the spacecraft only had 69 kilobytes of memory, which is very little compared to today's standards. To maximize the use of this limited memory, the Voyager team designed the software to be highly efficient. After the mission goals kept evolving, the team had to make several software updates, so that new tasks could be performed or bugs could be fixed. These updates were sent from Earth via radio signals, which take about 20 hours to reach the spacecraft. For example, when Voyager 1 was given the task to take the famous pale blue dot image in 1990, then the mission team had to specially reprogram the spacecraft so that it could point the camera towards Earth. Diagnosing and solving problems remotely became more difficult as the Voyagers moved farther from Earth because the communication delay kept increasing, making real-time problem solving harder and harder. The team has to send commands to diagnose problems based only on the data received from the spacecraft. It can take them several hours or even days to see the results. One incident happened in 2010 when Voyager 2 started transmitting confusing data. After analysis, the mission team identified that one bit in the computer memory had flipped from 0 to 1, which was causing a problem in the data processing system. A series of commands were sent to reset the system, and after that, the spacecraft returned to its normal operation. This was a huge achievement, especially when the spacecraft was about 9 billion miles away from us. Dealing with aging hardware, the Voyager spacecraft are now over 45 years old and their systems have far exceeded their expected lifespan. Clear signs of aging are visible in components like thrusters, gyroscopes, and communication systems, and the mission team has to find creative solutions for them. For example, the spacecraft's thrusters, which adjust its orientation, have been working for 4 decades. Because the thrusters have become inefficient, they require more power, which is often used to perform maneuvers. To conserve power, the mission team reprogrammed the spacecraft so that the thrusters are used less frequently and there is more reliance on the reaction wheels. At another point, when the mission team discovered that Voyager 1's primary communication antenna was becoming off target due to changes in the spacecraft's orientation. To solve this problem, the mission team developed a new strategy using a combination of thrusters and reaction wheels to keep the antenna pointing correctly. The Voyager mission team used creative solutions to address the spacecraft's aging system problems. In some cases, the team even developed completely new techniques to reduce hardware failures or limitations. For example, when signs of wear started appearing in Voyager 2's gyroscopes, the team developed a new method to determine the spacecraft's orientation. They repurposed the data from the star tracker, which was originally designed for a different purpose, so that the antenna keeps pointing towards Earth and communication remains possible. In 2019, Voyager 2's dropping power levels forced several instruments to be shut down. The mission team identified that due to the sudden voltage drop, the spacecraft had triggered a power protection mode. To prevent this problem, the team reprogrammed the spacecraft so that critical systems could be given priority and the instruments would remain operational under all circumstances, no matter how much the power levels fluctuated. This is one of the biggest challenges for the Voyager mission team. Maintaining constant communication with Voyager across such vast distances. As the Voyagers move farther from Earth, the travel time of the signals is also increasing and their signal strength is continuously getting weaker. Because of this, communication is also becoming increasingly difficult. National Aeronautics and Space Administration primarily uses its deep space network to communicate with the Voyager spacecraft. That means it uses the Deep Space Network, which is located in California, Spain, and Australia. A worldwide network of large radio antennas enables constant communication. For example, in 2012, National Aeronautics and Space Administration upgraded the Deep Space Network antennas with new receivers, which had higher sensitivity. So that they could detect even the faint signals from Voyager 1 and Voyager 2 and pinpoint their precise location. Signal delay and data transmission is a unique challenge in communicating with Voyager, and that is the long time it takes for signals to be exchanged, a significant time delay. Currently, it takes about 21 hours for a signal to travel from Earth to Voyager 1, and it takes another 21 hours for the response to come back. This round-trip delay is almost 2 days, which makes real-time communication impossible. And that's why the mission team has to carefully plan and sequence their commands. It will be to maximize the efficiency of data transmission. The visors use a technique called data rate reduction. In this technique, the synchronized data is transmitted by compressing it. This allows the spacecraft to send more data in a short amount of time. Deep Space Network then decompresses and processes this data on Earth, ensuring that no valuable information is lost. Precise antenna pointing and tracking are necessary to maintain a stable communication link with Voyagers. As the spacecraft are continuously traveling through space, the Voyager's mission team has developed sophisticated algorithms for this, which predict the spacecraft's trajectory and orientation with great precision. These algorithms consider planetary gravity, other celestial bodies, and the spacecraft's movement, and they ensure that the antennas remain accurately locked on their target. In 2020, Deep Space Network underwent a major upgrade to improve its capabilities. In this upgrade, National Aeronautics and Space Administration added a new 34-meter antenna in Madrid, Spain. This upgrade further enhanced Deep Space Network's capabilities so that it can easily communicate with distant spacecraft like Voyagers, and to ensure that they remain in contact with Earth for as long as possible. Future of Voyager missions. Now, as the Voyager spacecraft continue their journey into interstellar space, eventually, one day, their power levels will drop below the minimum threshold needed to operate the instruments or communicate with Earth. National Aeronautics and Space Administration estimates that after 2025, the RTGs won't have enough power left to keep the spacecraft systems operational, and when that happens, Voyagers will go silent. And their historic mission, which was providing us with valuable data, will come to an end. But even after the power runs out, the spacecrafts will continue to wander in this infinite space. With their golden records, which are a message from our human civilization to those aliens of the future, a testimony of our existence for those intelligent aliens who might someday reach these spacecrafts. The journey of the Voyagers represents humanity's first step into interstellar space, which is beyond the boundaries of our solar system. They have expanded our understanding about the outer planets, about our solar system, and have revealed many mysteries of the heliosphere. This mission has also provided us with valuable data about the Kuiper Belt and the interstellar medium. Their legacy will continue to inspire our future scientists, engineers, and explorers. Conclusion: looking towards future space exploration, Voyagers. They remind us that when we push the boundaries of our knowledge and capabilities, nothing is impossible. Their remarkable journey shows human curiosity and ingenuity, and their story isn't over yet. Even after falling silent, the Voyagers will continue their journey through this cosmos, carrying our message to the stars. Friends, what do you think? Share your thoughts in the comments. If you like this video, be sure to like it and share it with your friends. For more videos like this, make sure to subscribe to the channel and press the bell notification so that you don't miss more deep dives into space exploration and scientific discoveries.